Alright, in this video I'm going to show you how to simplify radicals that contain variables. The first problem you see is the square root of 8x cubed. So now you understand how to simplify the numbers. So for the number 8, you know that there is a perfect square, so you can break 8 down to 4 times 2. However, here's what you should do. Now, when you don't have a number for your index here, it's actually considered to be 2. So what you want to do for your variables is break it down into 2's, because then that would be a perfect square. For example, x squared. So break it down to as many x squareds as possible. And you can only break it down to 1x squared, and then what's left over, you have an x left over. X squared times x is x cubed. So what I want you to do next is put equal, put some space in front of your radical, because some things will be taken out. For example, the square root of 4, for example, is 2. So a 2 will come out for that. This 2, however, will stay in because you can't find the square root of 2. The square root of x squared is x, so x will come out because of that. However, this x will stay under the radical because we don't have enough x's to make a perfect square. So your answer is 2x radical 2x. Let's go to the next. Square root of 45 x to the 5th y to the 7th. Alright, we can break down 45 into 9 times 5, of course. And let's break down x to the 5th into as many x squares as possible. So you can break down as x squared times another x squared times an x. If you add these exponents, you get 5. Also, y to the 7th, y squared times y squared times y squared times y. Let me also note that you could do this a totally different way and get the same result, but I find that students understand it better when I break it all the way down like this. But there is another way which you may consider easier. Some people may consider easier. However, I found that this way students seem to grasp this method faster. Alright, now let's begin taking things outside of the radical. So we need some space in the front of the radical. Let's go down the line. Square root of 9 we know is 3, so we take that 3 on the outside. 5, however, is not a perfect square, so it stays on the inside. Square root of x squared would be an x, but we also have another square root of x squared, which is an x. So we'll put 2 x's out here, but x times x is x squared, so we write x squared instead. This x right here stays on the inside. Let's go down the list. So we already found the square roots of that. Now we have to find the square roots of y squared, y squared, and y squared. So y for all 3 of these, y times y times y, will give us the y cubed we need to put on the outside. However, this y will stay on the inside. So the answer is 3x squared y cubed radical 5xy. Let's go to the next problem. We have 180. How can we break 180 up? Now I know there are some perfect squares in 180. I know that 9 can go in 180, but if I divide 9 into 180, I think I would have 20 left over, and 4 is in 20. So it looks like 36 is the perfect square, because 36 times 5 is 180. And then for 8 to the 4, and let me just show you this. A to the 4th is already a perfect square, but again, I like to break it all the way down so you won't be confused. Break it down as a squared times a squared, and break b to the 6th as b squared times another b squared. Alright? Let's go down the line, so let's leave some space in front. Square root of 36 we know is 6. 5, however, stays under the radical. Square root of a squared is a. Square root of another a squared is another a, so a times a is a squared. Square root of b squared is b times another b will give us b cubed. So the answer is 6a squared b cubed times the square root of 5. Lastly, cube root of 40x to the 10th y to the 8. Notice that I changed examples because I wanted you to know what to do if your problem was not a square root. It's a cube root in this case. So now we have to work with perfect cubes. So cube root of 40. Now 40 can be broken down to the perfect cube 8 and then times 5. Now x to the 10th, we're not going to break it up into 2's anymore because our index is 3. So we need to break up the x's into 3's. As many x cubes as possible. So x cubed, for example, x cubed will give me x to the 6th. Another x cubed will give me x to the 9th, and then I have 1 remaining, so I need to put that x there. Then y cubed times y cubed will give me y to the 6th, but it says y to the 8th, so I only have y squared left. Put some space in front of your radical. Make sure you put your index, or else it will be square root. Okay, make sure you specify your index, cube root of something. Alright, cube root of 8 is 2, so you put your 2 on the outside. 5 stays on the inside. Cube root of x cubed is x, cube root of x cubed is x, cube root of x cubed is another x, so x cubed goes on the outside. This x stays on the inside. Cube root of y cubed, cube root of y cubed, that's 2y, so y squared. And this y squared stays on the inside because we don't have enough y's. Alright, so your answer is 2x cubed y squared times the cube root of 5x y squared. Alright, stay tuned for the next video.